and welcome back to AWS On Air here from the Venetian and AWS reInvent 2022. I'm Steve Roberts, developer advocate for .NET and PowerShell. I'm joined by...
AM Grabelny, developer advocate for Game Day.
Awesome. And in this segment, we're joined by our partners, Pini and Ohad from Mobileye. So guys, tell us a little bit about yourselves. What do you do?
Okay, so Mobileye is all about saving lives and making the road safer. And
no big deal, just saving lives. Okay.
And we've been doing it for 20 years.
Oh.
We started off with a camera-based driver assistance systems. And again, if you're driving a modern car, most likely you have one of our IQ chips, which is our compute platform that runs inside the chip and runs the computer vision technology that powers the emergency braking, lane keeping, adaptive cruise control, these kind of things. And now, more than 100 million cars later, we're doing it yet again and pushing the envelope with road safety through autonomous driving. Now, again, we're working on building Robotaxi services, but also consumer vehicles with autonomous driving in them so that they'll drive anywhere and everywhere. And we do this through, again, really advanced AI and machine learning that runs in real time on the car, but also through the mapping the world for autonomous driving.
Okay.
So just the whole world?
The whole...
Yeah, just the whole world.
No big
every
deal.
Every road on it. Right?
Other planets next after the world?
That's next.
Yeah. Okay.
We're waiting for Elon to get us to Mars.
For sure. Yeah,
then
obviously.
we'll do it there.
Now, the adaptive cruise control, I first experienced that not too long ago, just a couple years ago. I bought the first car that had that. It felt like one of those times when you are like, I live in the future.
Yeah.
For me,
yeah, I remember my first time.
It was amazing. You would set it, it would track the car in front of you and adapt.
Yeah.
And you
should drive one of our autonomous driving vehicles.
Yeah,
it will feel great.
Yeah, that I have yet to experience, but I'm very excited. Very excited.
So you said a couple of things in that intro that sound like huge technical challenges, right? Real time.
Yep.
The device is on the car.
Embedded
in the car, right? So we don't have access to huge racks of compute power to do all this work, right? And anticipating challenges, mapping. So how did you overcome some of those challenges? What do you do?
Yeah, so one of our major challenges is to solve the sensing problem, which is actually we need to a perfect perception of all objects in lanes in surround system with extremely low mean time between failures. So Mobileye developed a very powerful chip that is also a cost aware. It makes the challenge even bigger because we need to, squeeze many models. Eventually, most of the computer vision problems is solved by deep neural networks. So we need to squeeze all those models together into a cost-aware, low-power chip without compromising the performance of each model because we need high accuracy for autonomous driving. Right. So Mobileye is a pioneer, even in software and hardware, mostly for autonomous driving and ADAS solutions.
That's always the challenge with embedded programming, isn't it? Is you've got a limited footprint, right? And maybe that footprint will expand, when new chips come out, things like that. But you can't depend on that now. You have to put something out. So you can't just come in and build a bigger model. You have to squeeze in all of the performance that you can.
You have something that runs on the battery of a car.
Right.
Right.
Yeah. No. Also, no big deal there too. I didn't even consider that.
Yeah.
So you actually have to think about an algo engineering solution because the software is progress faster than the hardware.
Right.
So we build a shared backbone, to squeeze all those models together. And in order to build this kind of model, you need a massive compute resources. So this is when we met AWS and our partners with Abana. So we will be able to train all those models in a very efficient way on AWS based on EC2 DL1 instances and achieve a very high accuracy. That's it.
I mean, when you're talking, assisted driving and autonomous driving, these are clearly different problems. But is there overlap in the solutions to this problem?
There is a lot of overlap.
I figured there was.
Driving assistance systems are usually done on a budget.
Okay.
right? You have a single camera. It needs to be, everything needs to be packaged and then be sold to a consumer.
Right.
Right? So you can't mark up the car.
It can't be prohibitively
You know,
expensive.
You can't add,
Right.
you know, for the price of the car. You know,
Right.
the buyer would have it.
No.
Right? So it's like one camera, and you do a lot of compute over there. But autonomous driving, also, if you want to take it beyond robotaxis, which, you know, you can put a pretty expensive rack there, but if you're going to sell it to the public, it has to be affordable.
Right.
Right? So you still need to do it on a budget.
Yes.
As you have many more sensors because you need to cover 360. You have a tighter envelope, like a bigger envelope to cover, right, of things you need to anticipate and deal with. And the thing is, you still need to do it very efficiently to run in real time.
Right.
Right? And these models, like these AI models, they're big, like they're massive. You're getting information for like 12 cameras, a bunch of LiDARs, radars. We have actually 2 different sensing systems that run in parallel.
Really?
One just from cameras, the other one's from LiDARs and radars. So, you know, every sensor has its vulnerabilities.
Yes.
They do not overlap, so you get a much more robust system. But that means that you need to do everything twice, right?
Can I ask real quick, too, and the audience might be thinking this as well. LiDAR, I'm familiar with radar. I think most people are. LiDAR, I'm familiar with ground penetration testing, right? Like, people use LiDAR to see through the ground. What are you all using LiDAR for?
No, actually, we're trying to use cameras as much as possible.
Okay.
And LiDARs are just a redundant system.
Oh,
Right?
interesting.
Again,
Okay.
we,
It's
as
there
Mobileye, we believe in
safety.
cameras. Cameras are our favorite sensor,
Okay, interesting.
right? And as Ohad said, just the sheer compute of training these models is very expensive.
Yeah.
Of course, development cycle needs to be fast if you need to keep it up to date and update your models. So the cost here is a real issue, right? And that's why when we partnered with Habana Labs on AWS, we managed to bring down the cost and be able to run on the same budget, just train much faster and much bigger models, which gives you better accuracy and better performance. So you can detect things faster, more accurately, and without needing to do too much compute, right? You can still fit it inside a small footprint.
I mean, that's vitally important. All of us in tech know this, I think. The general public, maybe not so much. A lot of this technology to do the things that we are thinking about that are way off into the future already exists. And it's already, you can do it. But you can't really pay for it because it would be way too expensive. So reducing the cost is just as important.
It's essential.
Yeah,
you can't,
that's amazing.
Otherwise, it won't be it won't be viable.
Right, and it won't be deployed in mass.
I told you a little bit about, we need to also map the roads, right? So, right, for autonomous driving, we believe that you need high-definition maps. And that's just not your navigational map that you just drive in your car as a human.
Right. That's what I was
They
curious
have to go down to the lane mark, to the single, every stop sign, every turn, every and at centimeter level accuracy on the road in 3D.
Yeah.
Right? And think about it, you need to do it for millions of kilometers around the world, like just basically covering all the roads of the world. And of course, that in itself is done not in real time at the back end, but again, it's a massive, massive big data compute. And you have to make it cost efficient, because otherwise you won't be able to sustain it.
But you have to use that in real time in the car, right? So if I'm driving a car down a road, right, I'm looking at the road signs, I'm looking at the other vehicles, the lanes. I'm processing things real time in my brain, right? In like, oh, somebody might run out behind that bus, right? So does the mapping play into that, in that you anticipate that, hey, there's a bend coming up or there's whatever?
Yeah. So again, the map, the autonomous vehicle detects in real time, right? But it also it downloads a recent map, like an updated map of the area that it drives, and it keeps updating as the road changes, because we keep updating that map in the cloud, right? And it compares what it sees with a map, localizes within that map, and then what it can do is it can actually see around bends. It knows what to anticipate. It knows that it needs to change lane now because there's going to be an intersection that it can't see because, for example, a truck is obstructing the way, right? No line of sight. But the map gives you beyond that. It gives you like the extra sensors that you need. Right? But it's more than that. The way that we can build the map is we use those same driving assistance systems that we talked about before. We have millions of them.
Right.
And we upload the detected objects from the lane marks, the road structure from each drive, and we combine them, but also we get the insight of all the drivers that were driving there.
This is fascinating,
yeah.
but we are over time. Unfortunately,
Yeah.
I have to wrap this. I don't want to, but I have to. To me, it sounds like the road ahead is always changing,
Yep.
and Mobileye is out there anticipating that.
Yep.
Also, Steve, he said kilometers. You'll have to translate for me later.
All right, I'll do the math for you
Thank
later.
you.
Yeah, you're good.
I'm American.
I
I
know,
apologize. You know.
Imperial.
Anyways, we will be back with more from AWS. Thank you both for joining
thank you.
us.
Thank you very
Thank
much.
you.
Stick around.
Right.